Hi, I'm Sean Gannon, and this is Minute Math. And today we're going to learn about differentiation and apply the chain rule. We're going to differentiate each function with respect to x. So if I was given this function, y equals x to the third plus 3 all to the fifth power. Okay. Well, I want to see if I can break this down really as two functions. We have the power on the outside, and then what's inside the parenthesis. So if I label my f to be x to the fifth and my g to be x to the third plus 3, right here we would have our f of g being written right there, right? You can imagine if I took the x to the third plus 3, I could plug it in for that x, and so I had f of g, which would give me my whole function here, x to the third plus 3 all to the fifth power. So I do have my f of g right there, and so when we find f of g prime, eventually we're going to need f prime as well as g prime. Well, f prime, we've written right here, f prime is 5x to the fourth, and g prime is 3x squared. Okay? So now when I take my derivative, dy dx, we're going to take f prime of g, f prime being 5, parentheses, whatever is going to be that g part is going to go in for that x there, to the fourth power, right? G, we know, is x to the third plus 3. And then we're multiplying it all by g prime on the outside, which is 3x squared. Okay? Now, you won't always need to write all this out. A lot of times you can see it, say, okay, fifth power comes down, subtract it by 1, using the power rule, keep the inside derivative on the inside. That's the way I like to see it. But we can write it all out right there. Now let's simplify this. The 3 times the 5, or 3x squared times 5 is 15, x squared. So we have dy dx here. As my final answer is 15x squared times x to the third plus 3, all to the fourth power. There we go. So let's recap. We're given y equals parentheses x to the third plus 3 and parentheses to the fifth power. We label my f, this is an f of g, so f being x to the fifth power and g being x to the third plus 3. I can rewrite that here, so it's an f of g function. Seeing that I can plug x to the third plus 3 in for that x to make my f of g there. Then I found f prime as well as g prime. So the derivative of f of g prime is, when I took it right here, f prime of g. Well, f prime we found to be 5 parentheses x to the fourth power, but in the parentheses I put my g, so I put g in there for my parentheses. Then I multiply that by g prime. Okay. Now I simplified that. I simplified and multiplied 5 times 3x squared, and I got my final answer here, which is in my derivative, dy dx is equal to 15x squared times x to the third plus 3, all to the fourth power.